Hello, this is Aditya. So now we are going to do a group project where we are building a hardware software design system on a configurable SoC FPGA. The goal is to build a hardware software system where the HPS selects a BMP file from a library of images, sends the data to the Sobel edge filter, it is mapped onto the FPGA, and then we get a new image value. So for part 1 we are just doing the HPS. We are doing it for individual and collective. So in this I'm going to explain about the collective part. So the procedure is, in the folder we have a C file, a make file, and the 3 images .bmp files. So we insert the pen drive into the FPGA board, and then we run the commands fdisk, and then we mount the file onto the pen drive, and then we run it on the home directory because of the memory allocation issues of the Batman image. It needs a lot of memory. We run it on the home, and then we get the out bmp files. Here we can see that we get the out bmp files of Batman Joker, Lena out, and Boat out. And then after running this on putty, we go to the folder, and we see go to the collectively folder. You can see that all the out files have been generated. So this is the Batman Joker output file. This is the board out bmp file, and this is the Lena out bmp file. So that is part 1 of the project, which is the HPS one. Thank you. So now I'm going to explain part 2 of the project, which is integrating the HPS and FPGA. So from the original Sobel C code, we separate out the Sobel void Sobel function, and then we generate the RTL for that. So this is the logic for that. For the Sobel function, where we are defining the gradient magnitude approximations when you're getting the input. And then in the macros SOC underscore system UO, this UO, this is the memory mapping which happens where the output of the HPS goes as the input for the Sobel, and then we are getting the Sobel output at the end port, and this is the memory part. So this is the memory mapping between the HPS and the FPGA thing. Then we go to the program device, we run this thing. So we see that it's 100% successful, and then we go to the putty, and we see again we follow the similar steps. We mount the file onto the pen drive, we run the .sobel function, and we again get the processing image. We see that the execution time for Board and Lena is less, and Batman Joker is obviously more because of the file size. And then we go to the folder, we go to Sobel FPGA, go to collectively, HPSC. So once we come into the folder, we see that the out files have been generated. Let's just check it for once. So this is the Batman Joker out.bmp. So that is it about the HPS and FPGA interaction. That is about part 2. Thank you.